Hi friends, Kathryn Korostoff here from Research Rockstar, and I'm very happy to have a special guest with me today, Rich Howarth, who is the VP of Engineering for IBM Watson and Artificial Intelligence. And I got to meet Rich recently, online anyway, as we were discussing his upcoming session at the Insights Association Next conference, where he will be talking about AI, machine learning, and customer insights. So welcome, Rich.
Thanks, Kathryn. It's a pleasure to be here.
So we're very lucky to have Rich Howarth with us today because he really does have a great deal of expertise in this area. And in fact, Rich, because you are an expert, I was hoping that you might be able to help us out. I feel like sometimes there's a little bit of confusion about really what is AI and what is machine learning. We sometimes hear these phrases almost used to talk about the same things, and it can be a little confusing for those of us who aren't necessarily experts. Can you give us a simple definition?
Sure. As you said, these are often misunderstood and confused concepts, even though they've been around for a long time. So if you look at AI, machine learning, and deep learning, I wanted to talk about what those are. AI is used to refer to machines that can perform tasks, like humans, with human-like intelligence. And this could include things like understanding language, reading documents, answering questions, recognizing objects or sounds, and ultimately solving business problems, right? That's what we all are trying to achieve with AI. There's typically two kinds of AI that people talk about. The first is general AI, which is comparable to human intelligence. That's still a ways in the future. How far in the future is hotly debated in the industry. But since AI appears to be improving at an exponential rate, a lot of people think we're going to get there. But if you look at the way humans learn, it's through millions of individual experiences. It's constant reinforcement through other people and activities. And then that helps you develop context and common sense over many years. And this isn't really possible to replicate with a computer yet. However, most of the AI use cases today are what we'll call specific AI use cases. And these are highly successful. For example, image recognition has gotten better and better through AI. A good example is a doctor might want to take a photo of a mole on your arm, and AI can help that doctor understand if it's probably going to be skin cancer or nothing to worry about, right? So AI applications like that have become very, very widely used. Another example is medical journals. There's millions of medical journals about cancer treatments, and something like 25,000 new ones being produced every day. No human can consume that volume of information. But with AI, a computer can ingest all of those medical journals and help an oncologist recommend the best treatment. So these are really exciting use cases of AI that we're starting to see. Now, let me talk about how AI actually learns. It's through what we call machine learning. Machine learning is an approach to learning that doesn't require specific programming. Traditionally, when you wanted a computer to accomplish a task, you'd write a specific program to do so. With machine learning, the computer uses large amounts of data to train what we call a model to perform the task. Machine learning's been around for many years, and typically it's used statistical techniques such as regression, classification, or clustering of data. Now we're seeing deep learning. Deep learning is a type of machine learning that uses artificial neural network algorithms. These neural networks are inspired by the way the human brain works and are much more flexible than traditional statistical techniques. Deep learning is exciting, and most people who refer to AI are really talking about deep learning today. Recent advances in both cloud computing as well as the availability of GPUs have enabled these neural network algorithms to be run orders of magnitude faster than in the past. And we're seeing dramatic improvements and many new use cases and scenarios. So let me just summarize. Machine learning is how computers learn from data. Deep learning is a form of machine learning that's used for many of the AI use cases and again is modeled after how the brain works.
Excellent, thank you. And I love the example also of the image analysis. And I know that for people in the insights community, that's something we're very interested in as well, just because now we're collecting so much unstructured visual data. We are collecting a lot of images and video now as part of insights work.
Oh, exactly. And there's many use cases on video, right? So AI can now recognize scenes and image objects from videos. It can help. Well, it can provide you know captioning of videos automatically so that it doesn't have to be manually done. So tremendous amounts of unstructured data are out there, and deep learning and AI has applications to help us work with that data, understand that data, and use it more effectively.
Fantastic. I love that. Thank you so much, Rich. So I do want to ask, building on this topic, I had recently been reading a bit about the IBM Data Cloud and specifically what you refer to as the data catalog function. And it struck me as perhaps being aligned with something I know is a challenge for many insights departments these days. A lot of insights departments are trying to do a sort of amp up the way they consolidate a lot of different data. So if you're running an insights department, you might be conducting dozens of survey projects a year, so you've got all this data from questionnaires. You may be doing some social media listening projects. You may have data from customer analytics sources or web analytics sources. You may have data even from qualitative projects, and maybe even some of that unstructured visual data that we were just talking about. So a lot of organizations are trying to figure out a better way of making sure that they can have a central way of accessing all of that different types of data, try to break down some of the previous silos that would typically exist, and in general make it easier for people to have sort of a central repository, but that's reasonable to set up and manage. I think that a lot of times in the past there's been a sense that doing that kind of work is going to be extremely difficult. Can you tell me if data catalog would be something that we could use that approach to try to create that sort of central repository without days and days of setup per data set, if you will?
Sure. So first, let me tell you a little bit about data catalog. As you indicated, one of the biggest challenges associated with business analytics and AI and machine learning is getting access to high quality data. Often you don't have the latest version of a sales report. You have to go to a custodian that owns the data to get access to the data, and it's a significant challenge. So with data catalog, we're trying to make data simple. We're trying to provide easier access to data regardless of where it is, and as you said, make it very easy to use so that people don't have to go through some lengthy, complicated process to ingest a data set and apply a whole bunch of metadata fields. It can be done in seconds, very, very quickly. One of the things about our data catalog is so there's many different data indexes, data catalogs, there's full text search. And so what's unique about what we have? Well, there's a couple of things. First is that it's not just a data catalog. It's a catalog of all of the assets associated with AI and machine learning. So it can also store models and dashboards and reports and all of the information that you need. So after you use the data, for example, to create a dashboard or a visualization, you then can save that and publish it in the catalog as well. So that's a key factor, a key differentiator in this. A second one is that you don't have to have the data stored in our cloud. We recognize, as you said, there are data silos, there are data repositories all over the place. And what we're trying to do with our data catalog is bring those together and provide a unified metadata view of data sets and data assets that could be stored in multiple places. Some could be stored in a cloud, whether it's Amazon S3 or our cloud. Some might be stored in an on-prem data warehouse. And so our data catalog lets you bring those different data sets together and make them easy to access for your analysts, data scientists, and other users.
I love that. And so they still reside sort of where they originally reside. We're not getting into version control issues. We're not replicating things. We just have a seamless way of accessing it.
Exactly.
Love it. Beautiful. Well, I think that's fantastic, and I know a lot of organizations are trying to tackle that challenge right now. So, thank you for explaining that. Now, I do know that you do have a session coming up where you're going to be talking about some of these topics, and I really like the name of your session. The name of your session at the Insights Association next conference is "How to Monetize and Scale Innovation Through AI and Machine Learning." Can you give me an example of something you'll be covering in your presentation?
Sure. So, so I talked to a lot of companies, a lot of CEOs about, innovations and how to scale them. And it's something that I'm passionate about. What I see is that companies really struggle to create new products and businesses, and just very few are consistently successful. A lot of companies have figured out, how to implement a mini startup venture capital kind of approach where they have a funnel and they bring lots of ideas into the top of the funnel, and a few of them make it out the bottom of the funnel and end up becoming products. But at that point, companies struggle with scaling those innovations. And so the focus of my session is on what it really takes to turn these ideas and innovations into, big businesses for your organization or your company. And how do you leverage data and AI to be able to do that? There's a lot of new capabilities that have become available that you can leverage to better understand what's working, what's not working. Obviously, marketing analytics is using a lot of this and has been for a number of years, but I think there's new opportunities as we see continued growth and expansion of what you can do with AI and machine learning.
Excellent. I love this. It's very inspiring.
It is. AI is I think one of the most exciting areas in the entire computer industry. It's certainly getting a lot of hype. And people are wondering, is it going to meet the hype? I truly believe it is. And, the dystopian concerns aside, I think AI is going to revolutionize almost every industry, every job, every business, and in positive ways, right? Like, just like the example I gave with oncologists and not being able to keep up with the volume of medical journals being published, right? That challenge exists in every industry. And what we're focused on in IBM is AI to help people do their jobs better, to help companies operate more effectively, to help enable applications to be more productive for business users, those kinds of use cases.
Well, I think you'll find a very warm reception at the Insights Association conference because these are all things that are near and dear to our hearts. I think there's a lot of confusion and a lot of concern, but right now in the Insights profession, one of the things that people are most concerned about is, how can we use this to automate things that can be automated so we can spend more of our time as insights professionals working on the synthesis and the human value add, the so what analysis, and connecting it to the business outcomes. So I think there's a lot of concern about what's hype versus what's real, but I know sessions like yours are going to help clear that up.
I hope so.
Well, thank you, Rich. So again, thank you to Rich Howarth from IBM for being with us today. The next conference is going to be April 30th through May 1st in New York, and that is this year, 2018. So please do check out the conference for more information. Thank you and have a great day.